So pick one of the sides, let's say the left-hand side, and find out what is the left-hand side equal to. Change it until it looks like the right-hand side. Let's see. So the left-hand side has cosecant, which is 1 over sine of theta. And then I'll just leave sine there. And this has two terms separated by subtraction. So I need to combine these two terms so that there's no more subtraction somehow. Well, to combine them, I need a common denominator. So for the second one here, I can multiply on the top and the bottom by sine of theta so that I have sine of theta in the denominator. And then I can combine them as one fraction with sine of theta as the denominator. And it turns out that 1 minus sine squared is the numerator. And since it has sine squared, then I need to think about identities that have sine squared, like for example sine squared plus cosine squared equals 1. Or if I subtract both sides, subtract sine squared from both sides, I would have cosine squared is equal to 1 minus sine squared. And so I can replace this sine squared, 1 minus sine squared, with cosine squared. Okay. Now how do I turn that into this? Well, sometimes when you get stuck going this direction, you can, at least on scratch paper, play with this one and see, well, what could that be turned into? So over here on my scratch paper on the right side over here, I've got, let's see, cosecant, which means 1 over sine. And I've got cotangent, which means cosine over sine. Well, this has a cosine over sine, but this needs to have sine and sine in the denominator. Well, if I need sine and sine in the denominator, I need another sine in the denominator, so multiply by sine on the top and the bottom once again. And now the denominator looks as it's supposed to, sine times sine. And then for the numerator, I've got cosine squared and a sine of theta. And I'm supposed to just have cosine, at which point I'm getting to be a little skeptical, wondering if this is even true. Maybe somebody threw in a false one to try and trick us. So if I try to make this one look like that one, I would have, so 1, so I could say this is 1 times whatever I want. So I've got the 1 in there, and then line that up over that sine of theta. Okay, take one of these cosines, so factor this as cosine times cosine. So take one of those cosines, so factor it as cosine times cosine, and then write down this sine so that we don't lose it. And for the denominator, it's sine times sine. So this 1 over sine is cosecant. This is the cotangent. And then this is extra stuff that we don't have in the original problem. So then I'm going to try and prove that this one is actually false. So one way to do it is plug in a number for theta, and if you can find one time when it's false, then the equation is false. So I'm going to try, I'll just pick a number 23 degrees. 10 degrees. So cosecant 1 divided by sine of 23 degrees minus sine of 23 degrees is that decimal. Now for cosecant, that's going to be 1 divided by sine of 23, and then multiply that. Just to make sure that it's clear, I'm going to put this one in parentheses and say take that one, which is cosecant, and then multiply with cotangent, which comes from 1 divided by tangent of 23. And then do we get the same thing, 2.16? No, we don't. And so sure enough, this one is false. As I could see down here, when I got this extra sine and cosine in it that weren't supposed to be there.